session. Are you still studying vectors?
Yeah.
Right. Anything new today in the past weeks?
I wanted to do equations of planes.
Plane. Oh, equation of plane. Yes, that's yeah, that's right. How do we define the plane? Yes. Let's go to. Do you want to share your board or you want to use the whiteboard?
Can we go as like a background sort of thing, because I don't really understand the topic.
All right. Yes, you can write anything here. Yeah, we can use vector to define a plane in the 3D space, right? Is that the case here? So you have used some imagination of the based on the vector sum, right? Have you studied the straight line? How to define a straight line in the plane in the space?
3D vector.
Yeah, by use vector, how to define the this is general notation. This is called a Cartesian form. The Cartesian form of the plane. Yes, linear function. Can you see? But they got three variable. They got a three variable. So you can see that if you keep any variable x, y, z, any of them a constant, then you will get a straight line. So what is that what you have studied, or have you studied any other form of the plane?
I think there's one that's
that is unity vector, right? Cosine phi, theta phi. I don't know this notation.
Might be wrong. I think it's parametric something.
Parametric. Did you use this one? You have used the zero. So this is if you use this, this is can we say this is called the Cartesian? This is called the plane, right? So this is a plane equation. This is a plane. This is a plane. So this is called Cartesian form. So this is called Cartesian form. Cartesian form. AN. So, and another one is called the vector form. Okay. They called a second form is called probably are trying to say it's called a normal unit vector form. Unit vector form. So because we have studied vectors, so we can use a vector to represent this fact. So in this case, you use R. Yes, R is a vector. Did the teacher write this? Use this as a vector? Okay, that's fine. Yeah. And this therefore, they have these two must be basically a vector here must be any vector in the plane must be perpendicular to this one. Can you see? Were equal to, I think this is, if you use your notation, that will just equal to the a vector. Dot product as again, this is a directional vector. Do you mean this form?
No, there was one that had like another formula. I don't know, maybe it's not for planes.
That's for plane?
Yeah, I don't think it's for planes.
Oh, that's alternatively, this is sorry, if I don't use this form, we just indicate, I don't know if you have studied the vector form of this plane equation. Alternatively, you can use this, but you can use a vector difference on the plane. So basically you can use R, or you can use delta R if you wish, but we use this notation. So this is R. I use my way to that's more familiar with me. So that is R2. There's a two vector difference, and multiply the directional motion direct vector of the plane were equal to 0. So probably we better to draw the 3D diagram, you see.
Yeah.
This is a 3D diagram. This is X, this is Y, X and Y. So if you have plane, so if you have plane, so let's just draw the plane somewhere. So if you have, plane like this, if you have plane like that, okay. This is a arbitrary plane. And so basically, if the plane have the direction, so that vector, so can we use the n? Did the teacher show you this perpendicular? This n, you see?
Yeah.
And this directional vector is perpendicular. We denote this as directional vector of the plane, and which is perpendicular to the plane, right? So therefore, any difference. So if you have r, so if you introduce another position vector, so what this is called the positional vector. If you have two positional vector, can use r, and this r null. R null is another one, which is different color. So you pick up two positions on the plane. Can you imagine that? So you can pick up the 2 points on the plane. One is called P, another called Q, right? And the difference between these two, do you remember? How can we work out this difference vector? I have to specify this first. So this one is R vector. This is R null. This is R null. You see. So this is just two positions, P and Q on the plane. So this is our plane. So this is our plane. Okay. And this is in the 3D. This is Y. This is X. Okay. So basically, this equation, if I just remind you, the difference between these two vectors is just this. Can you see? R minus. Do you agree? Can you see this is origin? Orange vector must be perpendicular to the normal. Must be perpendicular to the direction of unit vector.
Yeah.
So that is this is another definition, because this must be perpendicular to this plane. You see. So therefore, if you put this directional here, can we make this just longer? We can make this direction which longer. This is not this is 3D. This is 3D. All right. So this angle must be 90 degrees.
Yeah.
And what is this equation? Can you repeat this equation?
Oh, I think that's just the parametric form.
Another form, parametric form.
It's like
you use two angle, right? You use two angle to define that R, but are these two equivalent or not?
I don't know.
I don't think so.
Yeah.
Can we look at your textbook to see, did they use, so this is actually the standard description of the plane. You can write a Cartesian form, or you can use normal unit vector form.
Yeah, this is a polar form.
Polar form, okay, you have used different coordinates, so that's why. This one, if it's the polar form, that be this one. If you don't use Cartesian, then that will be the position in the space instead of X and Y. Then you will use the polar form. So polar will be, can we just draw the position vector? That is a position vector, right? Can we just draw the position vector like this? So the position vector that if you want to describe this position P, Okay, so you need to find the R is one variable, right? And another variable is the angle between this plane. Can you see? Can we just it depends. Polar coordinate. You can use this angle. Did you use this angle?
Yeah.
This is theta, right? This is theta. So this is y. This is x. It's called a polar. This is a z. Okay. Now in this case, you need another angle, which is a direction between the zeta axes, right? Can we use a phi here? That's right. In this case, the position can be determined by R. You can use this. This is just amplitude, right? Amplitude vector, and another variable is theta. The third one is phi. Yes. This is not this. This just represent a point, not the. This just represent a point in space. It's a polar form, polar coordinate. It's polar coordinate, right? Coordinate. I think you mix up with this idea with the plane, because this very first question is plane, isn't it?
Yeah.
But equal to 0. Is that equal to 0? That's interesting.
I don't know. I just made it up.
In general, it's not equal to 0. In general, this have can we call it D? In general, it's a non-constant. It's a non-zero. Yeah.
Yeah. How do we figure out the equation of a plane?
Well, actually, this equation we imply the equation we just write here. Can you see? Can we say this is our first equation? So this is the first equation. All right. This is this equation for the plane. All right.
Yeah.
And also this is also equation for the plane, but in the vector form. Do you want me to show that how can prove these two equations are equivalent?
Yep.
Yes. Well, you don't have, in this case, you don't have use a polar coordinate. You don't have to. You see, maybe not. Maybe you have learned different subject, different. In this case, if you want to prove this are identical, we don't have to use a different coordinate. We still can use a Cartesian coordinate. Do you agree? So basically, what we can do is that we can use the we can denote this as let me just rewrite this one, because this equation we can denote the directional vector as a 3 components. Can you see that? So these 3 components. Do you prefer to use a vector, or do you want to use a? You can use. Can we call this as ABC?
Yeah.
Or in case because you have used ABC, doesn't matter. We can use ABC. That just means the 3 coordinate in the Cartesian coordinate, right? Or if you wish, you can also write as AI plus BJ. Do you know this notation?
Yeah.
CK. Okay, these are equivalent. Okay, these two notations are equivalent. And another equation we have to specify is these vectors. Can you see? So this R. So this R we have to rewrite R as can we just use XYZ? XYZ, right? And another thing is we have to write R null. These 2 positions are on the plane. That is point, all right? So basically, we are going to rewrite this as in his component form. R minus R null dot product, this dot product, the directional unit vector is equal to 0. So basically, we are going to rewrite that as a component form. So because we involve here we involve the 3 vectors. So therefore, we have to introduce the 3 sets of the components. And because X null, Y null, Z null, can you see?
Mm-hmm.
So in this way, we can use the components to represent the 3 coordinates. Okay.
Yeah.
Now, first of all, can we just work out the in this way we can prove that the difference between these 2 position vector can be simplified as X minus X null, can we? Mm-hmm. Y minus Y null, not Y. You can try. If you can follow my idea, you can try. How about the Z components? We just based, yeah, that's right. Z, that's right. Okay. And step 2, now the step 2 is to work out this product. Can we call this is a different is can we call the D for difference? Can you see?
Mm-hmm.
Now, can we just use a component to represent this dot product? Do you remember how to find the dot product of 2 vectors?
Mm-hmm.
Yeah, the difference between 2 coordinates. That's right. Can you expand this? Can you expand this dot product? Maybe we needed to find this place. We don't have to discuss polar coordinate. Yes. Mm-hmm. No, be careful. The dot product will give you the scalar, not the vector anymore. So this will be the scalar now.
Mm-hmm.
You remember the dot product give you this. Can we just continue here? The dot product will give you the scalar. Do you remember?
Yeah.
So therefore, R take R null dot product, the directional unit vector, will be simply written as A X minus X null plus B Y take Y null plus C Z take Z null. You agree?
Mm-hmm.
So this is just coordinate of these 2 points, P and Q, right?
Yeah.
And according to definition of this plane, this product must equal to 0. Can you see?
Mm-hmm.
Can we net it to 0? Then that would be our new equation. That would be our plane equation. According to the definition, so that is why we use a vector to denote this equation. Yes. Okay. Okay. This is equation now. Can you see? This equation is our plane equation already.
Mm-hmm.
But can we just try and rewrite this one so that it will be similar to this one? How can we algebraically modify this expression so that this equation will be looks similar or the same even? You expand, yeah, you expand that. I think you are very good at studying math. Yes, okay.
And then
can we put all constants together? Yes. Can we now introduce another constant d to represent the sum of the constant?
Yeah.
Can we just use a d to represent d? Okay, can you rewrite this question? Because after all, it is constant, right? Yeah, you swap the left and right hand side. Good. Yes.
Yeah.
Can you see the identical formula? Can you see the identical equation we just obtained it here?
Yeah.
So that is how to denote the plane. Either use the coordinate or Cartesian form, or you can use the vector form. I think you mix these two ideas together. So you apparently, apart from Cartesian coordinate, you have studied the polar.
I think
form,
it's
right?
that's for like, yeah. I think that's just for normal vectors, and I mixed it up.
Oh, that's just one of the factors. So basically, you can. Good question. So you can either denote this point. Can you see if I just focus on simple? How can we draw that? If I just if I just focus on simple point in the 3D diagram, right? So then we just use the R. Did you see? You see other use with color. That's right. If you want to describe the position, any position in space, in the 3D space, then you can use the three numbers. So these three numbers, so can we call this a P? These three numbers could be X, Y, Z. That is what the Cartesian coordinate.
Yeah.
Or you can use R. We do. Well, I know this is just R. Can you see? R is equal to the magnitude of vector. R theta phi. Can you see? So I think you are discussing this idea, how to denote the position vector. This is Z, and that's our phi, right? So that would be this one, this angle. This angle will be theta. Yeah, you put the two different ideas together now. Yes, that's good. So you know how to derive the formula for the plane. That's good.
How do we?
Yeah, go on. Any question?
How do we use this to get the actual formula of plane, like the equation?
Say it again. What is your question?
How do we use get the equation of a plane?
Yes.
Like in practice.
Oh, they will either give you this form 1 Cartesian form or the vector form. So you can use either form, and knowing that it represents the plane. And we just prove that these two notations are equivalent. What
if they give us two vectors? How do we calculate that then?
If you have two vectors, how do we determine the plane? Is that what it means? What it mean?
Yeah.
If you only have two vectors, so basically, if you want to go to next page. Good question. So if you want to consider, if you have two vectors, how to determine the plane? Do you agree? And so if you have just, let me try. So this is a 3D diagram. Now X is Y is Y is Z. So if you want to determine the plane, you have to, first of all, you have to alternatively, you can we just use this notation here? You have to determine the plane. And do you mean you don't know the difference between the 2 points?
Yeah.
You have two planes, right? You have two vectors. Do you agree? You have two vectors, and these two, you want to use these two vectors to determine the plane or not?
Yeah.
Yeah, you can call this can we call this vector? Can you see? So that's how we define this one. Can we call this vector? Can we call this directional vector? Can we call this P? So can we call this R? This is our R. All right. We just write at the beginning. We just write the vector form. And to define the plane, we first of all, we have to define the another reference. Reference, can we call it A? This is vector, not constant now. Can you see? This is vector A. That is yellow one. Okay. And after that, we have to that if that is the way to define the vector. So you have to build these two. Imagine you have the plane. If you have the plane, that's how to say, which can we just introduce the two. Can we just introduce two vectors? So this time we are drawing the two vectors on the plane. That plane to be determined. Can you see? So these two planes, we can simply write this two vector as use different color. Will help you to understand this notation. This time, the purple one and origin one are lying on the plane. Okay. So you can imagine that. So this is how do we introduce the plane? So this plane, can we just imagine that plane is with different color. This plane is make it slightly different. Can you imagine there is a plane in a 3D space, right? And this time you have imagined that these two vectors, can we put the notation? This is just the direction. Can we put this called KB? Use different color. This is another vector called KB, right? And this called the LC. So obviously these two vectors B and C are lying on the plane, which should be perpendicular to its direction. Which should be perpendicular to its normal, the direction of the plane by definition. This should be plane. This is the direction of the plane. Can you see? The red one will be our aim. Can you see? That be determine the direction of plane. Because both B and C are on the same plane, right? So you can this time you can use the cross product property to make your point. So the cross product B and C, what is the direction of the B cross product C?
What is, I don't,
they must perpendicular apart from the constant. Can you see? Apart from the constant must be equal to n degree normal. Because we have assumed these two vectors are lying on the plane. See? So both B, so basically, so B and C are lying on the plane, right? On the plane. So therefore, this relation is a hold according to the cross product, right? So if you just can we just rewrite this direction? If we just shift that direction here a little bit. So if this is this is a purple one, this is origin one. I just change the direction slightly, and the direction of the normal, the unit direction of the plane must be parallel to this product. Does that make sense? So this is a B, and this is a C. This will be our N. So therefore, we can argue that says should I use this notation? If you use A, B, C to represent the notation, so basically we need to work out these components.
Yeah.
How can we write these two together? If these two planes are on the same plane and the product cross product, they must be the same. How can we define this? How can we write this plane? These determine the plane X, B, and C. How can we make that point? We also know the difference between these two. This difference between this another one is we just discussed this one. Another condition, the difference between these two, R take A. These can we just do additional vectors. R take A is this one. Can you see? So they're all these three vectors are all lying on the same plane, right?
Yeah.
And how can we make the things to determine that? So therefore, the equation according to our definition is that I just write that according to our definition. So basically, the R take A, right, is equal to this difference is also equal to the KB multiply LC. So that is according to the sum. Now, if we also, our objective is to work out what is N is.
Is that multiplied or plus LC?
Oh, this is plus. Can you see this is so this side? Can you see this vector plus this vector were equal to this vector?
Yeah.
Or the plus is this is plus, but this would be difference. This vector can put the Q here. So this is a difference. Can you see? This is R. This is R. Take A. Can you see that?
Yes.
These are the vector relations. But I think the question is, what is the original question? Is the original question if we know the vector R and A, right? R and A, how can we determine the plane? I think this question is incomplete because if you only know the two vectors, then you should have a number of planes as long as the plane were intersect with this straight line. Can you imagine that? If you only have two vectors and any plane, can we draw another one? Any plane will be can be satisfied this condition. We can draw another plane. Can you see? We can draw another plane, which is different with a different. As long as they just pass this as long as this intersect with this can you see? There's another plane. Can you see that? So both the purple plane and the blue plane will pass this the straight line determined by these two vectors.
Yeah.
I think you have to stick with this condition. Can we just check your question? We have to stick with this condition. How do we, basically you need a 3 point to determine the plane. Do you agree?
Yeah.
Do you have textbook? Can we just check the question in the textbook?
Yeah, I'll find it first.
Yeah, I will stop that. Because if the question is incomplete, we don't know what we're going, you see.
So what would we need to figure out?
Yeah, we can pick up particular question in your example or prompt questions in your textbook.
I can't.
Or you can draw, you can use white, you can copy. You don't if you cannot share your textbook, you can copy the let me find. I have reference. I have the, I think vector application is that's 9. Of 9%. Are you looking for your textbook?
I couldn't find any questions in the textbook.
Yeah. So basically you have to, this is a different textbook, but they are talking about the same thing. So you can either apply your knowledge to solve the problem. So the angle between the line and the plane. Can we just go to these particular questions? Let's go to whiteboard again. So let's consider more concrete example. Can we just copy the question for you? So the angle, how to deal with the angle, how to find the angle? That is more practical question. How to find the angle between a line in a 3D and a plane. Have you studied this part?
No, how do we do that?
Yeah, you still have, you basically need to, can we just draw the plane first? This is a hypothetical plane. So we got to say this is you have a plane, forget about the coordinate. We don't have to coordinate, we just draw the plane in a 3D, right? Then you have a straight line passing through this plane. And you have can we just say this is a straight line passing through that position? Can you say that's extended? This extended part. So you can imagine this plane. Can we just make it more real? So this is can you imagine this is a straight line intersect. This is the angle. Can you see there's angle between a straight line and this? Can you see this is a straight line? Can you do this straight line? So this is a straight line on the plane. So if you draw this directional angle, you have studied. Obviously you have studied this angle that determines this perpendicular to the plane. Can you see? So these are in this directional vector. How can we find this angle? Either this angle, can we just indicate that? That would be the angle, isn't it? That would be the angle, theta. So this is a straight line. So this straight, can we use a d? That's just vector. It's just vector d. Okay. And there's another vector which determines the normal direction of the plane. So this unit is determines the normal direction of the plane.
Yeah.
So how can we work out the theta? Or you can either use this one, this is called phi, but these also the theta. So therefore this angle, the same thing, all right? You can either work out this angle phi. So this is the angle. You can either use phi, or you can use work out that other angle, which is theta, which is just it's just equal to pi. Sorry, half pi take theta. Do you agree?
Yeah.
All right. Can you apply your knowledge to solve this puzzle? How do we work out the angle? Probably easy to work out the theta.
How do we figure out theta?
Yeah.
How do we do it? I'm not sure.
Yeah, but maybe we will give you more concrete. Okay, so basically this in this particular case, can we just write the equation for the plane? I use the example in the textbook that the plane is x plus 2y take z equal to a number 8. So this is an equation for the plane. Okay. And this time they also give you the direction of this n is also given. So the direction of the plane is given. You can see that you don't have, when you ask the question, you have to assume that which is given, which is not given. If everything is unknown, we cannot discuss, right?
Yeah.
For example, in order to find this the angle, these two conditions, the equation for the plane and also the normal direction must be given, right? Normal direction is 1 to -1.
Yeah.
Okay. Can we work out either theta or phi? In other words, you have to work out the you have worked out the direction of this you have worked out this tangent from the plane equation.
How do we do that?
Yes.
I don't know how to do that.
Yeah. So basically, do you remember how to write the direction of the plane? Sorry, we just discussed how to. Did you if you have learned this one, probably teacher will already told you that these 3 coefficient will give you a direction. So these 3 numbers will give you the direction of this straight line.
Does it?
Not a straight line, but the
direction
is a line. Let's see. Find the angle between the plane and the line with equation. Oh yes, sorry, they have additional equation. Have you used parametrical equation for the straight line?
Yes.
Yep. If that is the case, I can. Another condition you have to know is that this straight line. So this straight line. So this D is also given. They got the 3 components, right? It says x equal to t, 1 take t, and another is 3 plus 2t. T is the time. Okay.
We have to put this into.
So what says in that case, how can we determine the direction of this D?
We have to turn it into a Cartesian.
Yeah, this is a straight line. So this represents a straight line. Yes. Oh no, you have taken advantage of utilize this coefficient. These 3 coefficients will be used to determine this vector. I don't know how much you have studied. So this one, these 3 numbers can be used.
Or do we just match them up to this?
Let me see. Oh, hang on, I mix them up. So this unit vector is picked up from this purple number. I use the coloring. So these three are pick up this the direction. The normal direction of plane is by these three numbers. Can you see? The purple one. And this the direction of D can be simply used this one. Use these three red colored numbers. And right down here, just equal to 1, -1, and 2.
Yeah. And do we just make a cross product of it?
Yeah. How do we determine? Yeah. How do we work out that? See, the question has reduced to define work out the direction angle between two vectors now. After perhaps this notation is not very accurate. Can we stop here? If you use, I use the cross product or dot product.
The dot product.
Yeah, dot product. You wouldn't get the vector. You get scalars. Let me just remind you. So if you have a dot product B, right? So you have so if you just write this with x, ax, ay, az, and normally we just probably this notation is not very accurate, but that'll be all right. If you want to consider more accurate writing, so that is the formula we have to use. Ax, bx. Did your teacher show this result?
Oh, yeah.
Y, by, and az, bz. Okay, so basically a dot product will become a scalar because this notation is a vector, so it's impossible.
Yeah.
Unless it's a cross product. You see. If you are dealing with the cross product, that will give you a vector. You see. That is a vector. So please use this formula. Okay, this formula. The third one will be negative. Yeah, that's right. Yes, -3. That's right. So this is product. So how about angle?
Is it
No. If you use theta, it should be cosine theta, isn't it?
Oh yeah.
If you want to work out theta, that would be the cosine inverse, right? And the dot product of these two, which is n dot product, the d, right?
Yeah.
And divided by their amplitude, right? That would be the formula for the theta. Is that right?
Yeah.
So we know that the dot product. How about the amplitude for these two? So this is -3, right? The dot product is -3.
Once.
Yeah, that is n. Yes, half, right? Half, yes.
And then we have theta.
Yeah.
Yeah.
Yeah. Then of course, if you want to convert it to the phi, then that would be sine, right? Because that's different by 90 degrees. So in this case, cosine theta will equal to sine phi. Do you agree?
Yeah.
So you have just take care of that. But perhaps I want to emphasize what we actually discussed today. The most important thing is this one. When you want to prove this one, can you see? This is probably, can I highlight this important? Can you see? We have assumed ABC is components of this n vector. You agree? So therefore, eventually this ABC eventually appear in our equation. Can you see? This is a general equation of the plane. So therefore, whenever you see the equation for the plane in this standard form or Cartesian form, you can immediately pick up this n vector. Do you agree? So that is very important point.
Yeah.
So that is why when we solve the last question, page number 3, yeah. When we solve this question, so we can immediately obtain this one. Based on this equation for the plane.
Yeah.
Yeah, if you don't have textbook, I can pick up some question for you next time. All right.
Yeah.
And yes, this is yeah, because this time you can either using the simultaneous equations, or you can use the 3D graph, which is a plane.
Yeah.
So I think you will learn more, but if you know that so this is a good example, we can start the geometry and the algebra together. For example, if the plane, if the 3 plane have just one, they can intersect, right? You have imagined if the 3 plane can intersect, and which means that algebraically, which means they have a solution. The simultaneous equation have a solution. Right? Yeah. So basically, eventually, we can just write this general form here. So basically, in algebra, we are dealing with, say, we just say, so for example, we have the 3x minus y plus z equal to 6. I just write an example. And this is x plus 2y minus 7z equal to 5. And another is 9x minus y plus z equal to 4, for example, right? In algebra, this means 3 simultaneous equations, right? Yeah. But in geometry, that will mean the 3 plane in the 3D space. Do you agree? So therefore, whether this simultaneous equation has a solution will depend on whether these 3 planes will intersect each other. Yeah. Does that make sense? Now, if you next time you see this plane, if that is the case, if these 3 planes, if these 3 planes are the parallel in all the parallel, they never intersect. If that is the case, all right. This is one. This is another. There's another. And there's another one. If that is the case, what does it mean? Do we have
simultaneous equations?
There's no solution, right? There's no solution. They're just like the quadratic equation, that we don't have they have no real solution. Can you see? Sometimes if they have no intersect, they have no solution. Do you agree? So if they are all parallel, and they are not, those have no solution. Of course, in the special case, as this scenario, can you see? The plane can be intersect. So therefore, they can either have one or infinite number of solutions.
Yeah.
So I think eventually we're going to discuss this. We'll start the algebra and geometry together. Vector just a different notation. Sometimes the vector will help you to work out the geometry, right? Because that vector allows you to work out the sum, difference, and the dot product and the cross product. Well, if you just without learning the vectors, it's very difficult to imagine that what the graph looks like in the plane. You agree?
Yeah.
So therefore, I think today we probably just emphasize these three numbers will give you the normal direction of the plane. You see? Different planes have different n. If we can take these advantages in the problem solving, see, we can solve more problems. All right.
Yeah.
I hope that will help you to understand more. We'll save that. Okay, see you Saturday. All right.
I'll see you Friday, I think.
Oh, Friday. Okay.
Yeah, I'll see you Friday.
Okay, goodbye.
Thank you.